So in the last lesson, I introduced the concept of memory, and we talked about the three stages of encoding, storage, and retrieval. In this lesson, we're going to see how, while those three stages are pretty well agreed on, that doesn't mean that psychologists haven't developed a whole bunch of different models to layer over the top of that. We're going to learn about one, probably I think the most widely accepted model, which is the Atkinson-Shiffrin Multistore Model of Memory. Let me say that again, the Atkinson-Shiffrin Multistore Model of Memory. This is, you'll hear in this, as we look at it more closely, some of the language that you're used to in everyday life, because this has become pretty much the go-to model for how we actually put stuff into our memory system. So let's have a look at this diagram and unpack it a little bit to think about the different, it's called the multi-store model, so to think about the different stores, multi-store, many stores of memory that Atkinson and Shiffrin propose, and to see how it all works and fits together. So it starts on the left here, some kind of sensory information from the external environment. So in the last lesson, I talked about the Mona Lisa. So let's say I'm looking at the image of the Mona Lisa. So that's sensory information in the external environment. There's visual information. That needs to enter through the eyes and go to the visual cortex and all that. And so what Atkinson and Shiffrin said is it actually enters this special type of memory store called sensory memory. This is a really unique type of memory. It's got a very short duration, right? When I look at something, it's in this special sensory memory for only a fraction of a second. We'll talk more about that later. So I've seen it. It comes into this very short-term, no, I won't use that language, this very unique memory store called sensory memory. And if I don't pay attention, if I don't think about it, straight away, I can lose it, right? Most of what we look at and hear and touch, we lose straight away. We don't encode it and store it and retrieve it later, and well, then therefore unable to retrieve it later. Most of the sensory input we get is just vanishes because we don't pay attention to it. However, if we do pay attention, like in the example from last lesson, I'm looking at the Mona Lisa, I'm thinking about it, I'm processing it, then I'm starting to encode it. And then it enters, according to Atkinson and Shiffrin, the short-term memory. Now, we sometimes talk about short-term memory like, oh, I just remembered it for that day, so it was in my short-term memory. Short-term memory is actually much shorter than that, around 18 to 30 seconds. When they first created this, they called it the working memory. It's like a workbench, you know, the desk, and whatever you're bringing into your conscious awareness at that moment, you're putting it on the desk. It's your working memory. It's what you're actually working with in that moment. So that's the idea of short-term memory. It's sort of what you're consciously aware of at that time. And so it would go into our short-term memory if we're looking and thinking about it. But then, if we don't rehearse it in some way, if we don't work to encode it, then it won't be encoded into our long-term memory. So if we don't rehearse it, you can see here, it gets lost. So I looked at it, I thought about it for a minute, never thought about it again, information got lost. But if I look at it, sensory, I process it and I think about it and I work through it and I look at the different features, I'm now rehearsing it, I'm sort of going over it, and I'm attempting to encode it into my long-term memory. Now, if I then try to close my eyes and picture it, say the next day, what I'm doing is I'm taking it out of long-term memory and I'm bringing it back into my short-term memory. Remember I said that's like your working memory. It's like your desk, right? I put it away in the filing cabinet. The next day I bring it out again, bring it into my conscious awareness. I'm bringing it back into my short-term memory. Of course, things can get lost from long-term memory. We'll learn a lot more about that in some upcoming lessons. But theoretically, long-term memory is relatively permanent. You can have long-term memories that last a lifetime. And sometimes you think you've forgotten something, but actually it's still stored then in long-term memory. And what you've actually got is a problem with retrieval. You've got a problem bringing it back from long-term memory. I want to say one more thing about I'm going backwards here. So that was long-term memory, can keep an almost infinite amount. It has a virtually unlimited capacity. I'm going to try writing very messily. Unlimited capacity. It can store an unlimited amount of information, theoretically. And it is relatively permanent, right? It has a duration that's very long. I wrote permanent. Oh dear. Relatively permanent. So the duration is relatively permanent. It can last a lifetime, and the capacity is unlimited. You can store a huge amount of information in there. Going back to short-term memory. Short-term memory, I said before, has a duration of about 18 to 30 seconds. So it doesn't last very long. But what you can do is you can rehearse information. We call this, I think I might have cut off a word actually. That should say maintenance rehearsal. We can go over and over certain information to keep it in our conscious awareness, to keep it in our short-term memory. So we can use maintenance rehearsal to maintain it in there. Or we can use what's called elaborative rehearsal, which you'll learn about more later, to encode it more effectively into long-term memory. Learn lots more about that. So I said the duration was 18 to 30 seconds, and it actually has a capacity of, they say 7 plus or minus, so I got ahead of myself, plus or minus 2. So in other words, 5 to 9 things. 5 to 9 pieces of information can be stored in our short-term memory, our working memory at any given moment. Going back another step, I want to focus in a little bit on sensory memory. So sensory memory can actually be divided up into lots of different U5 senses. We're going to focus on iconic and echoic. Now, just from the names, maybe you can guess what these mean. If you think of icons on a computer, you know, the little pictures, the little icons, they're small images. So iconic memory is visual memory. Now, your visual memory is very, very short. You're taking in a huge amount of information, right? Right now, everything you're seeing, that's a huge amount of data, a huge amount of information. And so the capacity is really big. It's taking in a huge amount of information, but it lasts a fraction of a second. It lasts, I've forgotten how many seconds. Oh dear. 0.2 to 0.4 seconds. A fraction of a second, you can store a perfect visual representation. You can see iconic memory at work in a couple of different ways. One is if you've ever done the bendy pen trick, the fact that the pen looks like it's bending is actually due to iconic memory, because you've got this fraction of a second storage of where the pen was previously, and that creates this illusion that it's actually bending. So that's one fun way to illustrate iconic memory. There's also a thing called the Sperling test, and in the lesson I'll put a link to it in case you want to check that out. What they do is they present multiple letters, more than you could possibly remember. And then they play a sound to let you know which part you need to recall. And so they'll flash them really fast, play a sound, and if the sound's high pitch, you just need to remember the top. And even though it's gone, you can still remember the top. If it plays a low sound, you can still remember the bottom. You can't remember it all because there's too much. But if it's within that 0.2 to 0.4 seconds, you can remember some part of it, which indicates that you actually had the whole thing for a fraction of a second. That was very confusing. In the lesson, I've got a video where you can check out a Sperling test and see how that works. The other one is that we're going to learn about for sensory memory is echoic memory. Now, echoic sounds like the word echo. So this one is sound, auditory memory. Auditory memory lasts for not very long, about 5 seconds. So like iconic memory, it's got a very short duration, only about 5 seconds. I think it's 5 to 8 seconds. and it's the same thing where you're actually taking into your echoic memory more information. It's got quite a large capacity, so more information than you realize. So both of these have, all sensory memory has large capacity, it can store a lot, but a short duration, it only lasts a second. To illustrate echoic memory, have you ever done that thing where, you know, you're on the couch, you're watching TV, and your mum says, do you want me to make you some dinner? And you answer, you don't hear, and you say, what? Oh, yes, I would. You say what like you didn't hear, but then a moment later you answer the question because you realize you actually did hear. What's happening there is you weren't paying attention, you weren't listening, so you didn't take in the information, but it was still in your echoic memory. And so after you've said what, you bring it out of your echoic memory, you realize you do know what your mum said, and then you answer the question. So that's something that I like to think of to illustrate how echoic memory works. Okay, a lot of stuff in there. We're going to be learning quite a bit more about the Atkinson-Shiffrin Multistore Model of memory. We're going to be looking at those three different stores, the sensory memory, short-term memory, and long-term memory. And we'll come back to this again and again because this structure, this model, this framework is how we will be thinking about memory going forward. Get into it, and I hope you find it as interesting as I do.